We're going to look at an introduction to dilation, similarity, and scale factor. Some different types of transformations are rigid motions, stretches and shrinks, and dilations. So rigid motions keep the same size and shape, and examples of those are translations, reflections, and rotations, and it means that two figures are congruent. So here's an example. We have two triangles. They have the same shape and the same size. So they're congruent, and there was a rigid motion from one to the other. Then we have stretches and shrinks, so those can change size and shape. Notice the second triangle is longer than the first. And then we have dilations. With dilations, you're still stretching or shrinking, but it's in all directions. With stretches and shrinks specifically, you might just go in one direction, but dilations, you have to go in all directions. So it keeps the shape the same, even though the size may change. And this means that two figures are similar. So notice they're different sizes, but they kept the same shape. And that's what we're going to be focusing on. We're going to look at a couple examples. The first one, we want to dilate the triangle by a factor of 2. So we're going to take all of the values and multiply both the x and the y by 2. And then we'll graph it. So notice, even though the size changed, the shape stayed the same. So these triangles are similar. Number 2, rectangle B is a dilation of rectangle A. What's the scale factor? So that means we're multiplying by one number from A to B, and we want to find what that number is. And we can do that by doing this number divided by this number, or the image divided by the pre-image. So we can do 8 divided by 5, and that gives us 1.6. So 1.6 is the scale factor, what we're multiplying A by to get B.